Hey guys, welcome back to the Philco Predicta holiday set. And as some of you probably have noticed in the description of the video series, it has changed. And I'll explain a little bit more about that later on in the video, but right now I'm still working on the holiday 9L37 chassis. I have everything underneath done now, including that last power resistor as well as that line bypass cap. So that's complete. The board's still pulled. We're getting closer with the work done on that to be completed. I'll show you that in a second. And of course I've got the high voltage cage pulled off of the Flyback, doing a final inspection on it. And I don't know if I can get a good shot of that, but you can see right in this area right here, okay, I had a big chunk of wax fall off. In fact, it was just laying here on the bottom, which is pretty common for the outer coating of these Philco Flybacks to crack and then melt off. So, you know, this one's actually in pretty good shape as far as that goes. It tells me it probably doesn't have as many hours on it as some other sets that I've seen. And again, this cracking and melting will not impact how the Flyback works. It's just a matter of, you know, if there can be any issues with corona and stuff like that coming out of this thing. So I probably, since that's all the way down to the windings there, I'll probably get some RTV sealant that is rated for high voltage and repair that, and I may pick at some of this and see if it's on there loose. If not, I may use some Corona dope and then lightly coat it with RTV, and I think it should be in good shape. Okay, so what we're going to do now is take a final ohms reading on this little Flyback and see if everything checks out. Okay, so in one of my earlier videos on this set, you saw me use my ICO Flyback tester to basically do a couple of things. First of all, verify from this point here, the plate cap of the high voltage rectifier, to this point of the horizontal output tube, the plate cap, that we do in fact have continuity through there. Okay, and the other thing that we did was we sent a sine wave into this part of the transformer and also found that that was good. So the next thing we're going to do is we're going to check the ohm measurements between these 2 points. So that's fairly easy to do. We will put a lead on this plate cap and put a lead on this high voltage rectifier plate cap. And hang on, I have a technical problem here. Okay, got my connections all fixed up there, and it looks like we've got 370 ohms, and we're supposed to have 385 right here between these 2 points. So that looks pretty good. The next thing I'm going to look for is between point D and point 5 on the board. So I see point 5. I don't know if you can see that on the board or not. I can see it. There's a 5 there. That denotes this little point right here. And that other point was D. Oh, which is right here. So we're looking for 12 ohms there. 12.4 ohms. Okay. So those two are good. Now the next point we're going to look for is between 0.4 and 0.3, and we're looking for 4 ohms. No, I'm sorry, we're looking for 13 ohms. This is 0.3 right here. I think you can see that. 0.3 or 0.3, and we're looking for point number 4, which I'm assuming is right here. And we're looking for 13 ohms. 12.9, close enough. So we're good there. Alright. Now we want to go between 0.3, where am I at? 0.3 and the letter B. So we're already on 3 here, and B is down here in the lower right hand corner. We're going to be on that little dude right there. Okay, and we're looking for 11 ohms. 10.6. Okay, good. So everything on our Flyback checks out. When we eventually get the set back together, and like I said, I'll do a little bit of repair work to the donut with some of that sealant, but we should be in good shape. That Flyback should work just fine, because we've checked it about every way you can check it. And so hopefully we'll be in good shape. Alright guys, coming along with the rebuild of the circuit board for the holiday. You can see here I have most of the caps replaced. I still have one cap right here to replace, and I haven't replaced it yet because I don't have the cap. It calls for a 0.0039, and that's a 10%er, and I don't have that. I'm also need to replace this resistor and this resistor, and I don't have either one of those values in a 2 watt, which is what that calls for. So I'm going to have to replace those 3 components. But other than that, all the resistors have either been left in because they're spot on, or they have been replaced. And you can see I have 1, 2, 3, 4, 5 of the 7 pin sockets replaced. So I've got to replace 2 more. And then of course I've got all the infamous K networks pulled. K2, K3, K4, K5, and K6, which need to be rebuilt and reinstalled into the board. So yeah, I'm just waiting on some parts, and then I'm going to go ahead and replace these 2 tube sockets, and then we'll be ready to move on to the K networks, which is always fun and a blast to try to figure those out and hope that you get it right. So when you reassemble this thing and connect all these connections back into the set all the way around, that you got it, and you got it right, and everything will work correctly. But I thought I'd demonstrate how to change one of these 2 pin sockets. I had someone comment that looks like it's a challenge. It's really not. It's really a very simple process if you are decent at soldering. They're really not very hard to take out and replace at all. So let me set the camera up in a tripod and see if I can show you how I do that. Okay guys, I'm going to demonstrate this as best I can, and hopefully I can keep everything in the camera shot. What we're going to do is take out this 9-pin socket and put in a new one here. And the first thing I'm going to do is just go ahead and get the these pliers in here and just start chomping on this plastic. And really you should wear safety glasses while doing this, because this stuff is old and brittle and it'll fly out of there. In fact, one piece, I don't know, just shot across the room there. But what I'm trying to do is get down to the metal and get this plastic out of the way. I don't know if you can see that or not, but this reminds me of my friend John from Arkansas on Joe Aaron One's channel, when he gets after his radios and does this chop chop. So that's really what we're doing here. And little pieces of flat plastic just go flying. But it takes a little bit of patience, just chopping away at this plastic. And again, this stuff's so old and brittle that it'll really just disintegrate. And wow, that one went flying too. And yeah, it just doesn't take a whole lot to tear that stuff up. You can see it's just shredding into pieces here. And it really looks like you're making a mess of things here, but you're really not. And then sometimes the metal really wants to stick to the plastic. I think that's just from heat expansion over the years. There we go. All right, and you can see there, that's what we're left with, is just some metal pins sticking out of the circuit board. So what we're going to do is go to the other side now, and hopefully that'll come in. And take this, hold it up like this. So this is the center pin to the original. And I'm going to go ahead and pop it. This particular center pin doesn't happen to be soldered into anything. Sometimes they are and sometimes they're not. And I'm just going to try to pull it out, which, there it is. Pulled right out of there. So now what I'm going to do, make sure I'm lined up here where you guys can see. All right, there we go. Sorry guys, I'm just trying to get it lined up where I can solder on this and you guys can see what I'm doing. Let me get the camera to focus. All right, so this is generally very simple. It's get my light in here on it to where I can look down through the light and see. There we go. So what I'm going to do is just go around the base of the pin right here. I'm just going to go around and I'm going to simply do a touch of the base of the pin on one side for 3 or 4 seconds. The other side for 3 or 4 seconds. Then I'm going to put the tip of the iron right on the top, just right on the top, and that'll heat the solder, and boom, you got a hole. It's just that simple. So one side, other side, top of the pin, and when that solder heats up, you can just poke her right on through. There you go. All right. So You just kind of work your way around. You don't have to put that iron on there very long. And by the way, this is a 40-watt iron. That's about all you're going to need working on a circuit board like this. As you can see, side to side, tip on the top. Let it heat. Just apply a slight amount of pressure. You don't have to force it. It'll eventually just pop right through there. I'm having a little trouble seeing because I can't use my magnifier. There we go. So you can see those holes are real nice. Side to side, loosen up that solder, tip onto the top, light pressure, and boom. So we'll go around and do all these. Tip on the top, down. Should have probably demonstrated a 7-pin. That's 2 less pins that we have to do, but I want to show you this because it's not near as intimidating as people think it. I mean, a lot of people think it's a hard thing to do. It's really not. It's not hard at all. Tip on the top, a little bit of pressure, followed right out. A little bit of heat, tip on the top. Boom, there we go. All right, so there's all of our holes. So the next, and then there's all of our pins down below, right here, that fell out. They all just fell right out. And here's what we're left with. All right. So now, what I'm going to do is get a little bit of lacquer thinner here and just really work over the board. Get all that dirt from out of there. Scrub it real good. And get some of my fancy pink Q-tips. And, you know, work the grime off the board that may have been underneath that 2-pin socket. Not too much. A little bit. But you want to get it good and clean. Alright, that's pretty good there. And get all this debris from this other one out of the way. Alright, so now we're going to take our new 2-pin socket, and these come with the pins a little bit spread out, so I usually just close them up a little bit, very lightly. Close them up very little. Make sure they'll go through the holes. And you just line it up with the holes and push lightly. And sometimes you'll hear it snap, but then you also know when you've got it in there. And there we go, it's in there. And then we go to the other side, and there they are. So now what I do is I usually come through with an X-Acto knife, and I go to the top and I just kind of wiggle this to the side a little bit. These pins are really bendable, just like wiring, and kind of spread them out so it'll help make better contact. But you got to be real careful with this. You don't want to get too close to that trace, pull it up in any way. And again, here's one right here. This happens occasionally where the hole wasn't quite big enough for it to get through. So sometimes you have to help them a little bit. There we go. Work on this just a second, folks. Let me get this one. Make sure I getting it in through the board. Okay. Alright, that's looking pretty good. Alright. So now let me set this up, show you. And we're going to solder this dude. Right there. Alright, so a little bit of, this is 0.032 solder that I'm using. It's very thin. And again here, you want to be kind of delicate here in this process, but you just go through, clean that tip a little bit, heat the pin here. Put your solder on the actual pin, both the sides and the top. And you can see there, just a nice, good, solid contact with the pin. Just like that. Make sure you get your pin warm and hot before you start applying solder. Just like that. Just like that. It's always good to get a little bit on the base before you start going to the top, and that really makes a good solid contact. Just like that. Okay. To the top. There you go. 3 more, guys. This is where a lot of patience is required in doing restoration work. Don't want to get in a hurry here. This is pretty critical to the operation of the set to make sure these contacts are good, solid solder joints. And like I said, to avoid pulling this board again, you want to make sure you do everything right. All the work that you do. All right, and there you go, folks. Take a little lacquer thinner once again and clean that off really, really good. And make sure you don't leave any flux or anything behind. And that's all there is to it. If I can get it to focus in here, what we did. There it is. All right. So that's it. Changing solder pins or 2-pin sockets is really not that big of a deal. It's not hard to do. You just got to take your time and make sure you know you make a good solid contact right here, and we're good to go. Nice and tight. And got one more here to change, and I'll have that part of the process of this board done. Okay guys, so now that I have most of the work on that PC board done, with the exception of these K modules, that comes to the reason why now this has become a dual restoration on both my Predictas, both my Holiday and my Barber pole. I started to redo these schematics for these networks, basically taking what it shows on the schematic and turn them into some type of form that you know, you can use to actually build one of these modules. And I reached out to Bob Anderson, who has YouTube channel B Anderson TV, and Bob was kind enough to share with me some photos of a previous rebuild of these K networks that he had done on a holiday set. I think he did it 2 or 3 years ago, maybe longer than that, I'm not sure. But I reached out to him to see if he had some of these schematics, because these things are kind of goofy in how they're laid out, particularly these flat ones, and to see if he had kept any of the work that he had done. And he shared with me these photos. Then I got to thinking, you know what, he's getting ready to do a pedestal set himself, and no doubt will be replacing the K networks in his set. So I just asked him, I said, hey, can I outsource this process, at least one set of these, to him, to make sure that I've got him all these networks, and I've got them where they are put together correctly, and I know that I can, you know, reinstall this board, and know that there's a proven way of going about doing this with proven materials. And he said sure. So I'm gonna outsource these rebuild of the K networks, at least one set, and then I will work off of that model to do the rebuild in my pedestal set. And then of course what you can do is encapsulate those in epoxy and paint them and reinstall them into the board, and they look somewhat similar to what these originals look like. Okay, so with that being said, I'm now switching gears, and I'm getting ready to pull the chassis out of my pedestal set. It's the same chassis, it's just laid out a little bit different. The tuner is up here. It's not connected right here to the chassis, and then of course the controls are not connected to the main frame of the chassis, and they have to be pulled. It's just a different cabinet configuration. And so what I'm going to do, instead of giving you a step-by-step, blow-by-blow of redoing this chassis, I will pull it out, we'll get a look at it, just an overall inspection look of it, and then just give you a few video highlights of how this chassis restoration is going. It'll be very similar to the Holiday, and of course this one's a little bit dirtier, has a little bit more cleanup. Of course all the tubes, all of that will need to be pulled and checked. So I'll give you some updates, but not as step-by-step as the last one. And then once I get to the point where I have the K networks reinstalled in this set, and then new ones built for the pedestal, we'll be able to do 2 power-ups at once. And then I'll have my Predicta project complete, and I can move on to other projects. So just wanted to give you that update. That's where I'm at. So the next video that I have, I'll have the pedestal sets chassis pulled out, and we'll take a look at that. Okay, appreciate you guys watching. I'll see you next time.